Hi, I'm Ed Amoroso from Tag Cyber, and I'm here with my friend Sri Mukkamala, who is the co-founder and CEO of RiskSense. And first off, did I say your name right?
Absolutely, Ed.
That
Thank you.
was that okay?
It was okay,
I'm so
absolutely.
proud that I could say it right. Hey, welcome to New York.
Thank you, Ed.
Now, I want to hear a little bit about you and about the company, about RiskSense. Then we'll get into the platform. But how'd you get into this? How did you get interested in cyber? And an interesting story.
It's an interesting journey. So started my journey at Indian Space Research, where I was working on neural networks for trajectory mapping. So found an interesting speaker called Vinod Dhawan, Satish Dhawan's son, and he was a professor at New Mexico Tech and learned about real-time Linux and then applied for my master's and my doctoral at New Mexico Tech. That's where I ended up in the middle of nowhere called Socorro. And then decided to start working on some interesting problems in AI. And fortunately, the DoD was looking for folks who can help them solve some very large complex problems using artificial intelligence. I was one of the first graduate students who was picked by the Department of Defense to really help them understand are neural networks the right method to actually study large-scale intrusions. That's the journey. I mean, started there, showed them neural networks are not the way to go. We built what's called support vector machines, applied for a patent, showed them how we can actually solve some very interesting, challenging problems in cybersecurity. That's where the journey started, and an opportunity came up called Cactus when we had two active wars, Iraq and Afghan. The Congress wanted to see how we can actually help our men and women get better cyber intelligence. So I was one of the chief scientists for the project where we were helping the government understand how would the mules actually build an IED, how would they use cyber intelligence to understand the troop movements better. The project is called Cactus, Computational Analysis of Cyber Terrorism Against the US.
So unclassified work?
It's a completely unclassified work outside the US soil, mining the web for understanding how a weapon is built. I mean, in this particular case, when we call weapons, we're talking exploits. How is an exploit built? What is the efficacy of an exploit? What existing defenses would it evade? And what level of skill does it need? So we did the converse. We started helping the government not only study what's out there, but started helping them look at how can we develop and mature existing exploits.
Are there some papers that can be read?
So there are quite a few papers we wrote.
You think people should take a look at some of the
Absolutely.
papers?
So it's a very interesting bill in the Congress as well. Even the summary of that sounds pretty interesting. What the industry is trying to do today, that's a project funded by Congress in 2003 to 2008, where we talked about information sharing that matters. We talked about crawling the dark web, trying to understand the attackers' movements, trying to understand vulnerabilities way before people can react to them. So it's a very interesting project. So that's the journey that's led us to believe that there is a need for work like that, and that led to starting a company called RiskSense out of New Mexico Tech, which is my alma mater, where the university still is the single largest shareholder.
I'll be darned. So connect the dots there. So you're doing that work and you got this idea and thought, hey, I'm going to start a company. Is that how it went?
That's exactly what it was. So I went to the university. I said, hey, this sounds pretty exciting. I think I'm finishing up my doctorate. I did my tour as an academician. I taught the classes, published 120 publications, have a patent. I said, now I feel like becoming an entrepreneur. Would you support me? The university said, we need an year to really reconsider your request, but we're open to a conversation. We said, why don't we just bootstrap it and offer research as a service what we built? So we started as RAS. We call it RiskSense as a service today. We said, how can we come in and consult to help you understand, do you have the right cyber strategy? It was really to help them understand their attack surface. That's what we were doing. But 2006, 2007, when you talk attack surface, people would look at you and say, what are you talking? So we had to dumb it down and say, let's help you understand what your vulnerabilities are and what threats you should worry about. So this is the time where the industry is very nascent. They were not even performing daily scans. Forget about quarterly scans, right? They were, at the most, they were doing quarterly, biannual or annual scans. So and they were not even touching application layer. They were not even touching database layer. So we found a very interesting thing. When you talk about attack surface, it's the three elements that would allow an attacker to come in. So we wanted to offer that as a service. The first year we made about $300,000 of nothing. Then I went back to the university and I said, hey, I mean, this is very promising. You got to think about it. Then they said, why don't we just bootstrap it? So we bootstrapped the company all the way up till for 4 years to really see if we can take a complex research, what we developed for the country, and really make it, consumer friendly or commercialize it. And we offered it as a service. In 2012, that's when we decided we should get serious about it and get our first employees. So we started hiring first 2 employees. Chris Acton, who's our employee number 1, is still at the company. He's our first employee. So we brought him as a full-time. And then 2012 to 15, we said, this is working out good. Now it's time to spin out of the university. So RiskSense was formally formed in 2015. That's when we said we have a product now, the RiskSense platform. We matured how we can actually do exploit analysis. And we also started helping the government and the industry predict very interesting attacks. We have a lot of things to our credit. WannaCry was actually called by our team 4 weeks before it was WannaCry. When we looked at Eternal Blue, the team was able to tell this will be vulnerable and will be the most impacted vulnerability that's been released in the last 10 years.
That's so interesting.
And in the journey, we wrote the first RFID malware. The fragmented malware was the first written by our team. And then we developed the first medical malware that would take EKG systems, endoscopy systems, and actually show how we can compromise them. Then we started moving into IoTs. We developed several interesting exploits for IoTs. The beauty here is anything we do, we tend to bring it back and correlate that in the platform. So that allowed us to take our knowledge, what we're developing, and really convey that message to the RiskSense platform. So in 2015, going back, the company was spun out officially. We're about 80 people now, and the journey continues.
I met you around that time. You and I were in a noisy cocktail party at RSA.
Absolutely.
I remember being very excited. Because I mean this in a very positive way. You and I are both kind of tech geeks, but you can talk business talk. Like, you can describe it in such a nice, acceptable manner. I can see how you've been so successful. It's wonderful. Now, there's a term that you use, system of record, that I know a lot of businesses think of. Help me understand, maybe you can explain what a system of record is, and then how your platform would help an enterprise security team improve their systems of record in protecting assets.
Absolutely. So this is a question we get asked all the time. Are you a vulnerability scanner? Are you a pen testing tool? What do you offer? We said,
what category?
What category you are. Are you a VTM, vulnerability and threat management? Are you a risk scoring platform? It gets pretty interesting after a point, right? They want to force feed you into a bucket. There's nothing wrong with that. That's how market looks at it. That's how buyers look at it. I make it very simple for people. Look at us as this way. Today, when you walk into an organization from a security stack, when you talk vulnerability and threat management, there are systems of record. Your network scanner, a Qualys, an Expose, a Nessus, is a system of record because you're running the scans and they maintain the records, right? And then when you get to your application, you can use an IBM app scan, you can use a Fortify, you can use a Veracode. You have different application security tools you do. And when you move to the databases, you have an Imperva, you have an IBM, you have a McAfee, you have a TrustWave. If you take a look at it, the security industry today from a vulnerability threat management perspective, it's still very fragmented. You're still trying to figure out, do I have one system of record or do I have 3 systems of record? And the beauty from an attacker...
Or 30.
Or 30. Because when you look at application security scanners, you have a proxy, you have a black box, you have a source code, and you have human testing as well.
Right.
So you're absolutely right. The interesting thing from an attacker's perspective is attacker only has one system of record. That's attack surface. That's all he cares. Can I infiltrate through an app layer? Can I get to the database layer? Can I get to the system layer?
It is easier.
Or the vice versa. He has 3 entry points multiplied by the number of vulnerabilities to do 100,000.
Right.
So you have a number of combinations you can use to come into a system. So when you call a system of record, for us it's very simple. When you have vulnerability scanners that are system of record. Today organizations use CMDPs, content management databases, as their systems of record, a ServiceNow or a BMC and so forth. So you have your asset information there, you put your criticality information, your user groups and so forth. Then you can start extending it. You can have SIM from a system of record perspective, from your alerts. When you get to your perimeters, you can have your connectivity as a systems of record. So the layer continues. Where RiskSense is, we don't compete with systems of record. That's not who we are. However, there will be a converse thing. What we call ourselves is a true intelligent layer. We call ourselves an intelligent mode. Today you have so much data. So if you look at the systems of records are very good at producing and storing a lot of data. They generate data. The problem we have in the industry is it's not lack of data. Do we have quality data? And do we have the right type of data so we can make some informed intelligence decisions? That's where RiskSense really plays. I mean, we call ourselves an intelligent layer or call ourselves as an intelligent mode. We take the data from the systems of record and really try to understand what patterns can we derive. In a vulnerability threat management, all it matters is which vulnerability will be used to break into a network, or which vulnerability would use to be compromise your attack surface. That is it. That's what matters. So then you can talk about prioritization. Then you can talk about enabling the team so they can fix the right stuff that matters. Then you can also start talking about how would I ensure that if I cannot remediate, what other enabling cyber technologies can I use to mitigate the effect?
Now, I want to back you up before we get to sort of remedy. You've got to normalize all that data. How hard is that? And can you lose? Are you losing information by doing that? Because all these proprietary formats and all this crazy stuff.
It's a very good question, right? I mean, I talked about data, and denoising is a big problem. I mean, you used word normalizing.
Deduplicating, denoising,
absolutely.
all that.
So it's a very important thing. That's where the recipe for success is. And that's where systems of record sometimes, what I call, tumble on themselves. Because they're constantly producing data. Are they producing the right information? Are they giving you the right stuff? And then, especially when you have multiple systems of record, your metadata is different. I mean, the way you present your data is different.
Microsoft says it's a high vulnerability. Your SIM says it's a low.
Absolutely. There you go. That's where it starts, right? Or someone says, we use a CVSS2, and well, our partner uses CVSS3, the Common Vulnerability Scoring System. The real difference in both of them is when you start looking at the critical vulnerability in CVSS3 is, can I use a vulnerable component to go compromise other components? That's the difference, but that's a nuance. How would your systems learn that and actually do it at large scale? So that's one way to look at it. And the other way is you start getting into unstructured data. One systems of record is we don't have is unstructured threat intelligence. Yeah, we have TIPS today, threat intelligence platforms, but they go through a lot of normalization. They go through a lot of denoising. But the key is when you get information sharing outside your TIP, when you get alerts outside your TIP, that all needs to be ingested and normalized and correlated. So when we get the different types of data from different systems of record, that's why you don't see one single system of record for cybersecurity, because network scan data looks very different than your application scan data, than your database security data. It's very different. That's where it starts getting interesting. And also, if you go back in your day in life, a network administrator truly doesn't work on application coding errors. An application coding guy might be looking at database, but rarely it's your DBA and your database team that actually does that. So however, the convergence is happening in a different way. When you move to cloud, everything is getting into one converged container. So that's where the normalization really, really is important, because you don't want to lose the fidelity of the data. While denoising it, you don't want to denoise an important aspect. And you still have to be careful to get the fidelity from the network, the application, and the database. Once you normalize it and once you have the data in a presentable form, in other words, from a machine perspective, we're still talking machine data, then we can take that normalized data to the next level of, can I correlate that with the known threats? The work what we did for Cactus, we've been doing it for years. So there what we do is we first look at the dark web, we look at publicly available threat feeds to see, hey, we're seeing these 10 vulnerabilities. How many of them have known exploits? That's the first thing we look at. We call it exploit susceptibility. A known vulnerability, a known exploit. That's the number one thing we do. So think about it as build a vulnerability index, build an exploit index, like what Google talks about PageRank. We just build vulnerability ranks and exploit ranks. Then what we do is we take a look at your asset ranks based on your criticality. That's when we're talking about, I already normalized your vulnerability feed, I already normalized your threat feed, I normalized your asset data. So once I have the normalized data set, then the magic starts happening. how do I take these normalized data sets and start building them into a matrix? Do I have an asset that has a vulnerability present, that has a known exploit? That's where it starts with. It's a 3-tuple correlation.
Yeah.
Known exploit, known vulnerability on an asset. Then you can start looking at secondary correlations, saying that is that asset critical to my network? Is that externally accessible, internally accessible? And then we look at, is that exploit surge happening? In other words, are attackers actually talking about it and using it in the wild? We pull in surge information as well. So your secondary information gets correlated as well. So you have the primary correlation and then you have secondary correlation. Then ultimately what we do is then we start re-ranking it. Okay, this asset, this vulnerability, and this exploit got to be addressed. So think about it. A human is very good at doing a single sort or a single correlation. However, humans are not looking at a multi-dimensional data set.
True.
And really what we're addressing is a multi-dimensional data set with at least 9 to 10 different variables. Think about it as a it's a multi-variable, multi-dimensional data set. That's where you can start bringing in artificial intelligence. That's where you can start bringing in mathematical modeling.
Your training in neural must have really helped with that.
Absolutely. So what we started with was first, and this is a mistake a lot of people make in cybersecurity. I mean, I'll be with 15 years of doing research, I can confidently say that. A lot of people start with a machine learning algorithm. That's not the way to do it. You start with your data set. It took us 7 years to really make sure we understood our data set. There are a couple of things that go into it. One, can we ingest the data automatically? That's a number one thing. Can we parse, remove the noise, and ingest the data? That's the number one thing. Second, when you start putting everything into a matrix, is that a sparse matrix? How sparse is it? It's missing records, missing data, corrupted data, so you're getting into data integrity constraints. That is the killer for a machine learning. If you see overfitting or underfitting, or when you start looking at, I'm not getting the right learning models, that's because your quality of data is not that great. It's garbage in, garbage out. Your machine learning will only be as good as your data set. So that's the number one thing you got to do. And RiskSense has done a lot of work in actually building an amazing, amazing data set of vulnerabilities, of exploits, exploit search, known breaches from Verizon, internet search every single day on who is searching on what, and other publicly disclosed breaches. So I just did a webinar on that, and we'll be happy to share that as well. So the beauty there is we kind of let's take a step back and take a look at the data set we got today. One, to help you prioritize where should you focus. At the same time, also help you prioritize the type of cyber insurance you should hedge against. Because in order to do that, you got to understand the type of data you're actually dealing with. And that has to be more contextual to your own organization. You can't generalize that yet. Yes, there are some common patterns. Don't take that with a different view, but there are patterns where we can generalize. But majority of the time, it's very localized from a context standpoint, because every organization still tend to run things in a different way. So the beauty is you have the data set, and once you build your sparse matrix, then you start looking at which training method you start doing it. So you asked a very quick question. Now, are you moving towards the direction of neural networks? Absolutely. So what we're doing is, from a learning perspective, we tried logarithmic regression. That's where we started. Just log it to see what kind of results we would get on helping us predict the breach susceptibility. So when I talk about a breach susceptibility, what we're talking about is, given the known history of a particular vulnerability, the CVSS access matrix, can we comfortably go back in history and say how much time does it take to weaponize a known weakness and a known vulnerability? Now, very quickly we're able to tell if this is the common weakness used, if this is the common vulnerability, and if a particular access factor is weighting towards it, it's very likely that this particular vulnerability will be weaponized in 25 days. We're able to do that with 83% accuracy.
Wow.
This is very preliminary results as of the last couple of weeks. And we're seeing very, very interesting results. So that's one use case. Now we're moving to backpropagation neural network to really see what happens. And we're also going to go back and use my own dissertation work, the radial bias function of support vector machines, to really see what kind of results we're getting. And we're able to scale to 1 million assets. I mean, that's a very good thing when you come talk about artificial intelligence. we're able to actually very quickly do that to 1 million assets.
It seems like the last couple of years have been pretty interesting in AI. Like I read the Jeffrey Hinton stuff coming out and look at the advances in algorithms and even at the hardware level, like the graphics processors and things. And I think the deep learning would be the term that people use. Is that something you guys are taking advantage of? It seems like there's a big leap in the AI community, say in the last 2 years, just in terms of capability.
100%. I mean, I used to spend 6 weeks to get one model done. I mean, literally 6 weeks.
Right.
And I used to code in MATLAB, move it to Vika, and then come back, recode it. Today you have libraries everywhere, and you have so much, I mean, thanks to AWS and Google, I mean, you truly don't even have to know what
So
AI
much
is.
power.
Yeah, you can just pull an algorithm and try your model and see what accuracy you're getting. So again, that's a mistake a lot of people are making too. They're quickly coming in saying, I'm an AI expert.
There's so much power, you can do something.
Something,
quickly,
right? So the beauty there is, that's what I tell people, great, your model should have a domain expertise. If you go back and read artificial intelligence, deep learning, the names in themselves have what's called iterative learning. You're training your system at regular intervals so it can learn over a period of time and give you results. If you take a look at the mainstream AI, talk Google, talk Alexa, talk Salesforce, they use artificial intelligence in their core business processes. It's underneath doing the things to better enable them to predict a sales forecast, better search results, better shopping experience. So in cybersecurity, I mean, I tell them our goal is to better predict and prioritize a vulnerability. That is it. That's the problem we're going to do. So do I call myself better AI? My goal is, as long as if it can help you prioritize better than a regular mathematical function, I already fulfill my thing. So that's my goal. And that's where a human expert is very, very important. As a human, why do you think you're prioritizing a particular vulnerability? Why do you think this exploit is important than others? That domain knowledge is very important. We call it virtual tagging, or we call it labeling your data sets. It's very important. A lot of people forget that. In AI, your expert system, your expert opinion is more important than picking your algorithm as well. And people with AI experience will tell you that. That's one of the limitations as well. You constantly have to change. With cyber, things change every day. In other words, you need to reinforce your system on a very continual basis than what you would typically do for a fixed problem. When you're talking about character recognition, letters are letters. They're very fixed. That's where we do a very good job at character recognition than when it comes to image recognition, because of the quality, because of the change. So those exact simple things apply for cyber as well.
Fantastic. So are enterprise teams resonating with the message? Do they understand it?
Not really. No. That's a sad part, right? I mean, because I think AI and machine learning.
That's sad.
That's a sad.
Is it getting better?
It is. So I think. I mean, I think I wouldn't blame the customer before I blame the vendors.
Yeah.
I think we overplayed AI. I mean, that's the nature of the game, right? I mean, I just laugh. I mean, there are a handful of us who got our first generation PhDs with AI and cyber, right? I mean, Venki Lee from Columbia, Phil Chen from Columbia, myself. I mean, you have Vigna, who is the founder of, LastPath from UC Santa Barbara. So you can see the first generation of us who really got our AIs in cybersecurity. And when we see all these mushrooms coming up and saying, we are an AI too, I'm an AI too, I'm like, really? What are your credentials? I mean, did you publish a paper? Did you really work on real AI? What have you done? Right? I mean, it's again, because AWS has an AI model. Let me go run AI and I'll call it AI. Right? I mean, if you call that AI, great, right? So that's where the noise in the market is from. I'm AI too. Kind of, it's hard to decipher from a customer perspective. They don't have time to go figure out your credentials, what you have done, where you came from, and all that. They will just discount the whole thing. You know what, guys? We heard that enough. We will see. Can you operationally help me? So that's where the examples are used, like a Google or a Salesforce. They don't tout, I'm an AI company. They'll tell you, I'm good at search, I'm good at forecasting your sale, I'm good at doing a customer. They never say, I'm an AI. Yeah, they use AI too. All their CEOs say AI is an enabler and a differentiator, but not AI is mainstream, right? If you take a look at it, it's pretty clearly articulated. In cyber too, AI should be an enabler and really better do what your core mission is. If our core mission is prioritization, AI should help me aid in helping my prioritization better. If AI is to help me better understand my attacks surface, that's what AI should help, the breach predictability I talked about. If AI is the thing I want to go after, for cyber insurance, it's a very big problem. You have so many variables, and that's something we're doing as well. The type of insurance, think about it as nothing but a cyber exchange from a marketplace. We're looking at all the policies that are available. We're looking at your vulnerabilities and threats and saying, given what your densities are from a threat perspective, what type of insurance policy should you buy? We're not telling how much insurance, but we're telling you cyber insurance is 50 policies. Not everything is applicable to you, but you need to go 5, bind the 6, because given your data. So that's where AI should facilitate and enable, rather than saying, I am an AI.
Very refreshing to hear. Well, I hope you're out talking to a lot of customers, telling them the story. I guess deprogramming them a little bit and setting them off in the right direction. I hope things are going well. You enjoying being a CEO?
Yeah, it's a lonely job.
You can call any time.
That's
you need a
refresher. Absolutely. I mean, it's an interesting challenge. Ed. I mean, coming from academia, middle of nowhere from New Mexico.
You and me both. Yeah.
Absolutely. So I mean,
academia to business.
Academia to business. It's a very interesting transition, because truly enjoying it. There are several fellow CEOs who feel the same way. It's an interesting challenge, but at the end of the day, it's how do you take it to the next level?
Well, I wish you nothing but good success.
Thanks, Ed.
And thanks for coming by to see us.
Thanks a lot.
Next time you come back, we'll talk more.
Absolutely.
Great.
Super. Thanks a lot.
And we'll see you next time.